This video is going to cover fractional distance on a coordinate plane. This is more of a challenging question, so I'm going to go over this particular question related to fractional distance on a coordinate plane. It says, an ice cream truck driver has figured out he can maximize his profits by placing his truck along one of two routes. He could go from the school to a local neighborhood, or the school to the local park. Per city guidelines, he must park his truck no closer than a fifth of the distance between the school and the neighborhood, and a fourth of the distance between the school and the park. Our first step is to determine the ordered pairs for each of the possible locations. So let's start by looking at going from the school to the local neighborhood. What I want to do first is I want to calculate the two legs of this right triangle that we're creating between the three locations. So our vertical distance from the school to the park is a total of 16 units. And you can just count that, or you could look at the change in y values. And then if I'm looking at the horizontal distance between the park and the neighborhood, that is going to be 12 units. And again, I can calculate that by counting the units in between or by looking at the change in the x values. So for the first location, from the school to the neighborhood, I'm going to put S to N, school to neighborhood. That can be no closer than a fifth of the distance. So I want to take a fifth of 16, which is the same as dividing by 5 or multiplying by a fifth. So if I do 16 divided by 5, that's going to be 3.2 units. And now that's my vertical distance. So that means I could go down 3.2 units. And then if I'm looking at the horizontal distance, I want to take a fifth of 12. So 12 divided by 5 is 2.4. So that means I would go left 2.4. Now I'm talking about starting from the school. If I'm going from the school to the neighborhood, I would go down and then I would go to the left, right? So I want to look at the original location of the school. So the school is originally located at the ordered pair, let's see, 7, 9. So if I want to go down 3, let me write that a little bit bigger. So I'm going to be at 7, 9. That's my school. So if I want to go down 3, that's going to be taken away from my y coordinate. So I'm going to do 9 minus 3.2. And then if I'm going to go to the left, 2.4 units, I'm taking away from the x coordinate. So I'm going to subtract 7 minus 2.4. And that's going to give me the ordered pair of where the ice cream truck could be located. So if I do that subtraction, you should get 4.6 and 5.8. So that's about, let's see, 1, 2, 3, that's somewhere like right there. Okay, so that's one possible location, right? Now I want to look at So let me try and write that kind of smaller. I realize that that's kind of big. So for the school to the neighborhood, that would be at 4.6, 5.8. That's not the best looking for. It kind of looks like a Y to me. All right, now let me change my color. Let's write in a blue color. So I want to look at now going from the school to the park. That's a much easier calculation because you're only moving, well, the number 16 is divisible by 4, and you're only moving down. So if I'm going from the school to the park, and I'm going a fourth of the distance. So I'm going to take 16 and divide that by 4. That gives me 4. So I would just move down 4 units. 1, 2, 3, 4. Puts me right there. So that location is at 7, 5. So it says, how far is his truck in miles away from the school for each route? Okay, so let's start with the school to the neighborhood. So school to the neighborhood, again, if I'm going to look back at the triangle, and I'm taking a fifth of the distance between the school to the neighborhood. So I would like to determine the hypotenuse of this right triangle, and then I'm going to take a fifth of that number. So you could use the Pythagorean theorem. You could even use the distance formula. I think it's a lot easier just to use the Pythagorean theorem because we have the numbers 16 and 12. So here's what I'm going to relate this to. Let's think about the 3, 4, 5 triangle. Using the Pythagorean theorem, I know that 3 squared plus 4 squared is equal to 5 squared. Now the reason I wrote that down is because if I compare that to the numbers that I'm seeing in the right triangle that we have in the picture, I have 16 and 12. So I know that these are similar because all I'm doing is multiplying by a scale factor of 4. 4 times 4 gives us 16. 3 times 4 gives us 12. That means that the distance on the hypotenuse would be 20. So this full distance is 20. So if I'm taking a fifth of 20, well, 20 divided by 5 is 4. So from the school to the neighborhood, I'm going 4 units. Oh my goodness, y'all, that's not, I'm trying to spell units. 4 units. There we go. Okay, now if I compare that to my scale at the bottom, it says 1 unit is the same as 1/8 of a mile. So 4 times 1/8 is going to give us 1/2. So that's half of a mile. All right, now if we go back to, so I'm going to change again to the blue color. If we're looking at the distance between the school and the park, I did a fourth of 16 again. So that was also 4 units from the school, right? So if I'm 4 units from the school, well, we just calculated what that would be for 4 units. So going from the school to the park, it's 4 units, which again is the same. It's half of a mile. So then the final question is saying, if the ice cream truck driver parks at the closest allowable position, which route should he choose? Well, either route, because they're both equally far away from the school. They're both half of a mile from the school. So for C, I would put either route. Either route works. Either route. Since they're the same distance apart. Okay, I'm going to pause the video and rewrite my answers and try to make it look a little bit more nice so that you can see that in a second. Okay, so let me go ahead and show you on this next slide. So here's just a summary of everything that I went over, and maybe this is a little bit easier to see. So overall, we're finding that both locations of where the ice cream truck can go are half of a mile from the school, so it doesn't matter where the truck driver decides to park, since they're equally far from the school. I hope that this was helpful.